Number 66. Write formulas to illustrate the difference between each pair of compounds. So you're given three pairs. So here's a compound and there's a compound. Now remember, in ionic compounds, the cation is listed before the anion. That's the protocol. And so going over here, in A, we see the cation and the anion, and the other compound has the cation and the anion. So these compound names look very similar: lithium sulfite and lithium sulfide. So what's the difference here? You might think they'd be very similar. Well, they do have lithium and sulfur in them, but remember, for anions, if it ends in "ide," that's normal. So "ide" is, I'll just put this equals normal, and it's easy to look up what sulfide is. Okay, it's just the normal ion that sulfur likes to form. Sulfur is in the -2 column. And so for A, when you're talking about sulfide, that's going to be S minus 2. All right, S minus 2. Now, lithium is also pretty easy to identify. Lithium is in the +1 column. And so for both of these, the one on the left is going to be lithium +1, and on the one on the right is lithium +1. Okay, the only formula for the ion that we need to figure out is what's sulfite. Now, whenever you see "ite" or "ate," that's telling you it's a polyatomic ion. So I'm going to write that down: "ite" or "ate." If you see an anion ending in that, you should be thinking it's not normal, and it's a polyatomic anion. Okay, it's like a group of atoms that carry a negative charge, and thankfully you got a table that helps you out. It's table 3.5. Okay, you look up the polyatomic anions for sulfur, and here they are. Okay, so sulfite is SO3 minus 2. So when you see lithium sulfite, that sulfite is an SO3 minus 2. Okay. All right. So now that we know what these guys are, we can write the formulas. Okay. So now that you know the ions, you can make sure the positives balance the negatives. Remember, the amount of positive charge has to equal the amount of negative charge. And the way that you can do that, if this is a +1 and that's a -2, then you're going to need one of those sulfites and two of those lithiums. And so we could say that the formula is Li, 2, you need two of those, SO3. And to write the formula for this one over here, now that we know the ions, 2 lithiums and one of those sulfides. And so the formula is Li2S. And there we go. Check. So let's see if we can go more quickly for B. Okay, the first step is writing what these ions are. So you got your cations and your anions. Okay, the cations are pretty easy. Let's just write those down. Sodium is always a +1. Okay, going back to figure 3.2, sodium's in the +1 column. It's always a +1. So So for B, the one on the left, we're dealing with sodium plus 1, and the one on the right, we're also dealing with sodium plus 1. Now for the anions, you see eights, okay? So I'm not thinking that I'm going to be using this normal anion table, okay? You got to go down to that polyatomic anion table, and here you go. These are the ones of carbon. You got carbonate and then hydrogen carbonate, okay? Or it's also called bicarbonate. So carbonate is CO3 minus 2. Okay, that's the first one, CO3 minus 2. And then hydrogen carbonate is HCO3 minus. Okay, now that we got the identities of the ions, we can figure out what the formulas are. Okay, for the first one, you're going to need 2 of these sodiums and 1 of those carbonates. So the formula would be Na2CO3. And for the second one, you're going to need, well, they already balance. You don't really have to play that game. They already balance, +1 and -1. So NaHCO3. That's sodium bicarbonate, your baking soda. Okay, that's the formula for baking soda. And so let's move on to the last one, C. Okay, for C, over here on the left, you got calcium, and calcium, that's the cation, and then phosphate and dihydrogen phosphates are the anions. And again, calcium might be pretty easy. So going back to calcium, it's a predictable ion. You know, it's easy to tell it's predictable because if it weren't, it would say calcium 2, or it would indicate something in the name that says it's like one of these guys down there. But if you just see the metal name, it's telling you it's predictable. Calcium's in the +2 column, and so for both cases, we're dealing with calcium +2, and then calcium +2. So what are these? Phosphate and dihydrogen phosphate, again with the 8s. The 8s and the ites. You should be thinking polyatomic anions. Go to table 3.5. So these are the ones of phosphorus. Phosphate is PO4 minus 3. So you got PO4 minus 3. And then dihydrogen phosphate is H2PO4 minus. So that's H2PO4 minus. Okay. Now, looking at this one on the left, the charges do not balance, so we have to play that game. We need 3 of these calciums and then 2 of these phosphates. So the formula would be Ca3. And then phosphate, you got more than one element here, so you got to parenthesize it since you need 2 of them. PO4 and in parentheses 2. And there you go. And then for the next one, you're going to need 2 of these dihydrogen phosphates and then 1 of these calciums. So just 1 calcium, but then 2 of the dihydrogen phosphates. So parenthesize that. H2PO4 and then 2. And that does it. Check.